Hello, I'm going to show you how to use the RCompanion package's compmeansC function to generate mean comparison tables that you can use to make comparisons. I'm assuming you've already downloaded RStudio, and have installed the RCPA3 package. If you haven't done that already, you'll want to complete your setup before trying to use functions from the package. I'm also assuming you have a basic understanding of how to work in the R environment. If you don't know what functions and objects are, you should review Chapter 1 before practicing a skill from Chapter 4. The compmeansC function is one of the most powerful functions in the RCPA3 package, and we use it a lot in the book. The required arguments are fairly simple, but there are a lot of optional arguments and plot-related arguments which allow you to do a lot with the compmeansC function. In this video, I'm going to focus on the compmeansC function's required arguments and optional arguments that you might use with a basic mean comparison. I will cover other uses of compmeansC, like making control comparisons, graphing relationships, and hypothesis testing, which come up later in the book in separate videos. The compmeansC function has two required arguments. dv is set equal to the dependent variable, and iv is set equal to the independent variable. The compmeansC function supports a standard set of optional arguments. With compmeansC, you have options to specify observation weights, the dataset name, the number of digits you want to see after decimal points, and whether you want to print the mean comparison table to an HTML file in your working directory. The compact and ivlabs arguments aren't standard options, and you can use them for basic mean comparisons, so I will show you how to use them in this video. I will discuss the plot-related arguments and remaining optional arguments in other videos about the compmeansC function. To see how to use the compmeansC function, let's work through some examples. Let's demonstrate the basic usage of the compmeansC function. All I did before the video started was to load the RCP3A package using the library command. The compmeansC function is used when we want to show the mean of interval level dependent variable by categories of an independent variable. So the independent variable must be categorical, and the dependent variable must be interval level, which R would call a numeric. If you're not in that situation, if you're not making comparison or showing a relationship, or the variables that you're comparing, you're making comparisons with are measured at different levels of measurement, you would use a different function, not the compmeansC function. This function can do a lot, and this is one of 4 videos I'll make about the compmeansC function, but it can't do everything, so you got to know when to use it and how to use it the right way. So to use it the right way, you would enter its name, compmeans capital C, followed by parentheses, and there are 2 required arguments for a basic usage, the dv, the dependent variable, and the iv, the independent variable. And so for an independent variable, I'm going to go back to an old classic, the party ID. Let's do party ID 7 this time. Party ID 7. And then for our numeric dependent variable, I'm going to pick one of the feeling thermometers. Let's try big business. So this should tell me when I run it the mean of this dependent variable, feeling thermometer, toward big business by the 7 categories of the party ID 7 variable. We've got a mean comparison analysis, and it by default will create a plot for us. So we can see, let's first look at the table. So the table is a mean comparison analysis, mean values of feeling thermometer, big biz, by party ID 7. So it's got the columns for mean, the n, and the standard deviation. And then here's our 7 categories of party ID. And we can see that, to start with, the strong Democrats in the responses had a mean score of 43.98 for big business. There were 1,769 strong Democrats in the sample, and the standard deviation of the response, standard deviation of the dependent variable within that group was 22.69. And then it does the same for each group, separating the responses according to the value of the independent variable, then within each category, reporting the mean of the dependent variable, the n, and the standard deviation. And by default, it produces this plot for us as a bar chart that shows this same information in a graphic. So it reports strong Democrats. The bar is up to 43.98. So these bar heights are the means of the variable by category of the independent variable, and you can see perhaps some pattern between the feeling thermometer toward big business and the self-identified party identification of the NES respondents. So that would be the basic usage of the compmeansC function. Okay, left off with this standard mean comparison table showing the mean value of the feeling thermometer toward big business by the 7 values of party identification in the NES dataset, and along with the mean, it's showing the n and the standard deviation. Now I want to show you what other options and optional arguments you might use when making a comparison of a interval dependent variable by values of a categorical independent variable. So one, well, some of them are fairly standard. I don't want to go over these to say a lot of redundant information to you to make these videos excessively long. So you might notice here that the W argument is there to identify a variable to weight observations. The data argument is there if you want to specify the name of the data set and abbreviate the identification of DV and IV and other variables you identify. We've got digits. We've got printC if you want to print the table and any plots you make to a HTML file in your working directory. So those are our usual suspects that we have. What else you might do? So what else kind of specific with this compmeansC function could you use of the optional arguments when making a basic comparison? So one that you might use is plot equals f. So if you run, I showed before, if you a standard call of compmeansC will produce a bar chart of the means by default. If you get tired of seeing that or don't want to generate that, you can change the plot argument to plot equals f, and then it won't pop up the plot. You can say continue to look at the technical help information if you like. One argument you might use in addition to plot is the ivlabs argument, and this is similar to the ivlabs argument I showed with crosstab C if you watched that video. So the ivlabs argument is used if we want to overwrite the labels on the independent variables. So for example, these are numbered, but we may not want to see the numbers, or maybe want to strengthen or shorten some of these text labels for values of the independent variable. And this can be a nice way to make the table or plots that you make more compact, readable, and elegant. And the main thing you want to notice to use this ivlabs argument correctly, well, first is that it's set equal to a vector. So to create a vector, I'm going to use the C function for concatenate, and I'm going to make sure I have 7 values. 7 values because there are 7 different values of the independent variable. And I want to do this in the order that they're shown here, starting with the first row. So if I want to change this, I might say, there's no set rule to this. It depends on what your goals are here. My goal really here is just to demonstrate this to you. So it's a strong dem. I'll just say dem. And lean dem. Independent. I'm just kind of using some very abbreviated labels here, and then we'll finish this off with lean Republican, and then they are Republican. And I have one more row that I want to relabel, and that is the strong Republican. Let's give this a run and see what it looks like. So we should get a table comparing means. We get the same numbers as before. It's not radically different, but you see my abbreviated labels here, and that can be nice. Now, one thing I'll show you, I guess, is if we were to create the plot now, it wasn't very helpful with the table, but when we make the basic plot, well, it's still telling us that they're kind of long, but they're not really. You can see now that the labels on our plot are shorter, which is nice to see them abbreviated on a plot. And so when they are printed on the plot, they don't overlap the x-axis label, which is nice. Now you may be wondering, if you watch the compmeansC video, which has an ivlabs argument and a dvlabs argument, why there's no dvlabs argument here. The reason is with the compmeansC, when you're making a mean comparison, the dv, the dependent variable, is summarized by the mean. So you got a one number summary of the central tendency. You don't need to break it down by different values of the feeling thermometer toward big business, because the feeling thermometer toward big business can be summarized by the mean. So we don't need like multiple rows of a cross tabulation. And so mean is really the only label that we need, and we don't need a dvlabs argument. It's not an omission, it's just not necessary. So the only real arguments that I could think that you would use as options for the basic usage of compmeansC, like for chapter 4, could be that plot argument to set that to false if you don't want to see the plot, and then this ivlabs argument to relabel the values of the independent variable. And as I mentioned in the compmeansC video, the benefit of this, like ivlabs argument, is you can change the labels displayed on the table and the plot just for display purposes, and see the new labels in the function call itself without having to change or being forced to change the labels on the underlying NES party ID 7 variable, which is kind of nice. So I can have the effect that I want, but then for later usage, this NES party ID 7 variable is unchanged and would display the same way as it always has for other function calls. So you can have the effect that you want without having unintended consequences for your later analysis.